This video is about the nature of science. Before you get started with this video, I recommend that you complete your reading. Your reading is going to be from your textbook, section 1 out of chapter 1, pages 8 to 14. If you don't have a textbook yet, I will post the photos of the pages in Google Classroom. I do recommend that you keep a science notebook to take notes in, and that you take notes in any way that makes sense to you. You can do an outline, you can do diagrams or sketches with labels. You can do summaries. However you want to do notes is great. Cornell Notes is highly recommended, but you do not have to take them in that way. I'm never going to check your notes. I do recommend that you bring them back and forth to school because they will be very helpful to you in class. We will do daily quizzes every day, and most of those questions will come directly from your reading or homework. And you are allowed to use notes on quizzes, just not on tests. All right, welcome to science. In science, we are going to be talking about how we know things about the world. So this quote says, "Science is a particular way of knowing about the world. In science, explanations are limited to those based on observations and experiments that can be substantiated by other scientists. Explanations that cannot be based on empirical evidence are not part of science." So I think it's really important to set the stage for what science is and what it isn't. If we cannot do an experiment, collect data, repeat that experiment, make hypotheses, it's not really science. It's just talking and discussion. So we'll talk more about that when we get into some hard topics later this year. Okay, a few terms before we get started that can sometimes be confused because the way that science uses terms and the way that we use terms in everyday life are sometimes different. So a fact, any objective verifiable observation. We can repeat it, it happens, you can't really argue with it. For example, water boils at 100 degrees Celsius to 112 degrees Fahrenheit. A principle is a statement based on repeated experimental observation that describes an aspect of the world. For example, the greenhouse effect. We have a lot of repeated experimental observations that tell us what the greenhouse effect is and how it works. A law, a broad concept or principle. Laws usually explain how something happens. They describe patterns in nature. They are often accepted as facts. Examples are Newton's laws of motion, Boyle's gas laws, the law of conservation of mass. A theory is an explanation of an observed phenomenon. Sometimes when we talk about theory in everyday life, we don't really talk about it the way that it's meant to be talked about in science. Theories in science explain why something happens. So it tells us why we observe things. So it organizes all of our facts and research to explain how something happens. It can't become a fact or a law. That's not how it works. It's not like a stair step where you start here and then you go here and here. They're just different things. An example is evolutionary theory. And when we get to that unit later this year, we'll definitely talk more about that. Science is always based on experimentation and observations. That means it changes all the time because when we learn new information, we learn new things and we change what we understand. There isn't always one way to do an experiment, but a lot of times when you hear the scientific method, they kind of mean that it follows a general sequence of asking a question, conducting background information or research, making a hypothesis, testing your hypothesis in an experiment, analyzing your data, drawing conclusions, and communicating them. And then often it's a cycle because you keep going around and around. So in the asking question phase, they often arise from observations that we make. An observation is a description of something that you can feel with your senses, seeing, smelling, touching, tasting, or hearing. It is not an opinion. It is something that is objective. If you say something is red, it's red. It's not going to be something else. An example, the ground is wet. That's an observation. Your inference is why you think that happened. So it's a guess about what happened based on your observations. You can make a lot of inferences. For example, if the ground is wet, you might say it rained, or you might say someone was watering the plants. There's a lot of different inferences you can make, and you're going to take in all of your background information to help you make that inference. In this picture, it's kind of a silly picture. It's from 1980. I want you to see how many observations you can make that are objective and what are inferences that you can make. Notice that I just made one. I said it must be from 1980, and I'm making that inference based on a lot of observations. So I just want you to pause the video for a second and think of how many observations you can make and how many inferences you can make. So some of my observations that helped me make that inference was the style of dress that they're wearing, the cars in the background. I noticed that they look like they might be a family based on the different ages that are there and the fact that they're standing close together. Anyways, there's lots of different things that you can, observations and inferences that you can make based on this photo. Also in the asking questions phase, we sometimes in science, we talk about the difference between qualitative and quantitative observations and data. If it's qualitative, it describes qualities that are not measurable. Examples, the color of something, how large something is without actually measuring it, the taste of something, the smell of something. Quantitative observations always use numbers or quantities to measure something. For example, you're telling me the exact distance or length that something is. It could be 4 feet long. It has 6 exact legs. It weighs 7.2 grams. So you can actually measure and record a number. In this picture, what kind of qualitative and quantitative observations can you make? After you make those observations, you can also make several inferences about what's going on in each one of the pictures. When you are doing quantitative data, it has to be precise. So how close your measurements are to each other. So even if your measuring tool is off, they should all be similar to each other if you do it more than once because you're trying to be precise. Is it consistent? Accuracy is how close it is to the actual value. So if it's actually 100 milliliters, you should actually be measuring 100 milliliters every time. That's accuracy. And then it's how correct your data is. Always try to get the most specific reading possible. Don't round up. If anything, you're guessing at the last decimal place, and we'll practice that in class. So these different targets and points basically tell you the difference between all of these. So the top left one is precise and accurate. They're all in the same spot and they are very close to the center of the target. These are all precise because they're together, but they're not accurate. So maybe this person's bow is off when they're shooting the target. These are accurate because they're close to the middle, but they're not precise because they're not all grouped exactly next to each other. And then this one is neither accurate nor precise because they're all over the place. When you are doing background research, it helps you find the purpose for your experiment. A lot of times background research will be done for you and I'll give you a handout to read. Sometimes I'll have you research it and see what experiments have already done or what people already know about it, but that helps us figure out why we're actually doing the experiment. Remember, the goal is to answer a question, and our observations lead to questions which lead to research. What do we already know? And it helps us figure out our purpose of our exact experiment. A statement that clearly shows what question you are trying to answer is the purpose or your objective. So you can say that in a lot of different ways. And then you construct a hypothesis. It's what you think might happen, and it usually includes a reason. So it has to be testable. We have to be able to prove it right or wrong. And it has to be based on observations. And then it has to describe a cause and effect relationship, and it has to have a reason. So here's your example or your format. So if your independent variable does this, then your dependent variable will do this because of this reason. For example, if you said, if I water the plants more, then they will grow taller because plants need water to grow. That one's really simple. So before we jump into hypotheses, we need to make sure that we understand what independent and dependent variables are. Independent variables are sometimes called your manipulated variable. It's what you are changing on purpose or manipulating in the investigation. When we graph it, it's on the x-axis of a graph. It is the only thing that is different between different experimental groups. You can only change one thing. For example, you want to do an experiment to see if what you drink before a race affects how quickly you run. You're only changing that. You're not changing anything else. The dependent variable is dependent on the independent variable, or sometimes it's called the responding variable. It's what changes in response to the independent variable. It's usually on the y-axis of the graph. It's what we're measuring and recording. Any kind of data, you can have more than one. You can measure and record lots of things. So if you're doing the experiment to see if what you drink before a race affects your speed, then your dependent variable is your speed. All right, for practice, you're going to complete the Understanding Hypotheses assignment that is posted on Google Classroom. Please reach out if you have any questions.